This is question 19 from GATE 2020 EC paper, which deals with memory addressing for a 16K byte memory bank. Underneath the question, you will find the title of the NPTEL course or video that is relevant to this topic. So let's proceed to solving this problem. In this problem, we require knowledge about memories. So a little bit of background first. Memory is a data storage device, right? So the idea is that there is an input and output bus. Sometimes it could be two separate buses, but doesn't matter for the purposes of this problem. And this is of course the memory, and there is an address bus with a read, write, and maybe an enable signal to perform the read or write. And if it's a read, the input data is placed into the memory, and if it's a write, it is the data from the memory is fetched onto that bus. So now inside the memory, of course, are various memory cells or memory locations, and these locations will be able to hold a fixed number of data. It will be a byte, which is 8 bits, or even a bit sometimes, and that depends on the memory concerned. But yes, a memory is just an array of memory cells, each capable of storing a certain amount of data. In our case, the memory cell, or a single addressable memory cell, that is, a memory cell is a portion of the memory which can be accessed by giving something as an address. That's what a memory cell is. So in our case, one cell of memory is equal to 1 byte of data, right? 16 kilobyte memory bank. And the memory of course stores 16 kilobytes, which is 16 into 1024 bytes, and since one cell is a byte, cells, right? So in our case, now we know that there are 16 into 1024 cells. How many bits are required to address this? If we have n address bits, we can address 2 power n cells. That's the idea with n address bits. So if we want to know for x cells what is the number of address bits required, since log to the base 2 of 2 power n is n, we'd have to do log to the base 2 of x, and of course the number of address bits has to be um, an integer, has to be a positive integer, so we'll take ceiling of that. And yes, so that is basically the procedure followed here. We want to know 2 power k is equal to 16 into 1024. So what is k? K is equal to log to the base 2 of 16 into 1024, which is 14 bits. And you didn't need to take ceiling over here because the logarithm itself gave an integer as an output. Thus the correct answer is k equal to 14 over here.